Okay, last lesson we introduced trigonometry. Trigonometry was talking about right angled triangles and talking about lengths and angles. There's some connection between the two. And the thing that connects those two things, lengths and angles, are what I call the three amigos, or three trigonometric functions called sine, cosine, and tangent. In this lesson, I want to go detailed and talk about tangent. I want to talk about this tangent thing, how it works. And what I told you last lesson was that tangent, if you find the tangent of any angle, remember an unknown angle is given by this little egg thing with a line through it, theta, the tangent of any angle, it's equal to the ratio between the opposite side to that angle and the adjacent side to that angle. Here's what I'm talking about. Let's say we have this triangle here, and we know that that angle there is 36.87 degrees. We know that this side here, which is the adjacent side, and this, which is opposite from it, so this will be the opposite side. We can see with the little grid lines, that's 1, 2, 3, 4. This is 4, we'll say centimeters, and this side here is 1, 2, 3. It's 3 centimeters. So what is the ratio between the opposite side and the adjacent side? Well, it's 3 divided by 4, right? The opposite side is 3, the adjacent side is 4. And what is 3 divided by 4? Well, for a calculator, if you really need me to do it, I'll do it for you. 3 divided by 4 is 0.75. So that is the same thing as 0.75. So what we can say here is that the ratio between the opposite and adjacent for this particular triangle is 0.75. And what this formula is saying is that that ratio is equal to the unknown angle, which we actually know down there, once we've taken the tangent of it. Now, how do you take the tangent of an angle? Well, it's actually pretty complicated, but all you need to worry about at this level is that to take a tangent of an angle, or the sine of an angle, or a cosine of an angle, you need your calculator. And when you have this calculator, a scientific calculator, how do you know you have a scientific calculator? If it's got these buttons on it, sin, cos, tan. You may need to look for it on your calculator. It should be on a scientific calculator. Any scientific calculator will have those buttons on it. So if I were to find the tangent of that angle, which was 36.87, according to this, if I find the tangent of 36.87, it should be equal to 0.75. Let's see if it works. So I'm going to punch in 36.87, and I'm going to hit the tan button, and it should be, according to this rule, 0.75. Let's see what happens. I'm going to hit the tan button now. Boom. Look at that. 0.75, roughly. But it is 0.75. So it's true. Now, I didn't just pick this number randomly. It does work out that way, that when you have a ratio between the opposite side and the adjacent side, and you take the tangent of that angle, you get 36.87, or that you get the same number, 0.75, the same thing. Now that works not just for the 3 to 4 triangle, it works for any other triangle with the same ratio of 3 to 4. So another triangle that would have the same ratio of 3 to 4 would be, let's say if we had 6 to 8, right? Just double it. 6 and 8 has the same ratio of 3 to 4, because 6/8 reduces to 3/4. So if I were to do that, I'd have the same angle. Let's see if that works. If I were to make a triangle, which instead of having a ratio of 3 to 4, having a length of 6 to 8, will have the same angle. Well, let's check this out. Let's make a triangle that has, instead of a adjacent length of 4, let's double it and make it 8. 5, 6, 7, 8, and then up 6. 1, 2, 3, 4, 5, 6. And then I complete the triangle right here, and look what happens. Now this side here is 1, 2, 3, 4, 5, 6, 6, and this is 1, 2, 3, 4, 5, 6, 7, 8, 8, 6 over 8 is the same as 3/4 because it reduces down to it, which is the same as 0.75, and look, the angle is exactly the same. And it works for even a bigger triangle. Let's say, let's go green here. Let's say we have another triangle with the same ratio of 3:4. We could go, how about 12? 12 on the adjacent side and 9 on the opposite side. So 8, 9, 10, 11, 12, 6, 7, 8, 9. Do the exact same thing, and look at that. That now green triangle, oops, green, has that same angle, and the lengths are on this side 9, and on this side 12. So, now this only works for this particular example thing, a 3:4 ratio, which is 0.75. If we were to find the tangent of that angle there, it's the same. Okay, a different triangle with different opposite and adjacent ratio lengths would have a different angle, but that angle always matches up with that same ratio number, whatever they are. And there's, of course, tons of possibilities. Which brings us to this. So, when you find the tangent of an angle by punching the button on the calculator, that value is equal to the ratio of the opposite and adjacent side lengths. And it only works for opposite and adjacent. For example, if I know, and you should know from Pythagoras triples, that the hypotenuse of this side would be 5. If I were to find the ratio of, say, opposite to the hypotenuse, which is 3/5, 3/5, which hopefully you know is 0.6. 0.6 does not work with that, and the tangent of that angle don't work. You're not going to get the 0.75 number. So that's why tangent and opposite and adjacent, they go together. And you're probably thinking, oh, I know, opposite and hypotenuse, something else goes with that number. The sine does, if you know from last day. Yeah, that's a different function, which we'll talk about next session. So what we're saying is that this formula, the tangent of an unknown angle, tan theta, which equals to the opposite over the adjacent ratio. Well, we can think of, what is tan? Well, tangent is like a translator. It's like a wizard between the two worlds of angles and side lengths. And it allows us to figure out some things. So using this wizard, this amigo, this function, if you have an angle, you can find the lengths of a triangle. And vice versa, if you know what the lengths are of a triangle, you can find the angles. And this is very handy stuff, used all over in all sorts of areas in the world where it's handy to know what the side lengths are and what the angles are. Okay, enough talk. Let's get to a real deal example. Let's see how we can use this tangent thing to let us go from a known angle to an unknown length. Angles to lengths. Here's how it works. Right angle triangle. The angle there is 33 degrees. We know what that is. What do we know about these side lengths? Well, what are these side lengths? This side length here is opposite that, so this is the opposite side, and this is the adjacent side. It's right next to it. And according to our formula, tangent of an unknown angle is equal to the opposite over the adjacent ratio. It's an A. I don't know why I did it like that. So there's our formula, and if I wanted to, I could do the whole formula work answer thing like I did in previous lessons. So the tangent of, and I actually know what the angle is, it's 33, so we'll put 33 in here. So tangent of 33 is equal to, the adjacent is right here, the adjacent is 7, so I'm going to sub in a 7. And the opposite, I don't know what the opposite is. It's this unknown x. Now I can put an x there if I want, or I could have just left it as O. Although when you leave it as O, it kind of looks like a 0, which might get confused. So it's just some unknown letter we'll put there. We don't know what that side is. We want to figure out what is the length of that side. It's unknown. Well, this looks like an algebra problem, doesn't it? I want to find this x. Well, in algebra, you see what's being done to the letter? Do the opposite. It's being divided by 7, so we're going to multiply by 7. Do the same to the other side. In reality, actually what I should do, in this case here, is, before we do that, let's first find the tangent of angle 33. So get your calculator, tangent of angle 33. So we're going to find 33 tan. By the way, your calculator may be the other way around. It may ask you to put tan first, then the angle. Just get used to it. Okay, and we get 0. Let's do the 2 decimal places, 0.65. 0.65 is what we get here, equals x over 7. And now it's just a matter of getting the x by itself, which is what I said before, times by 7, because the 7's cancel out. This is called cross multiplying, by the way. You're left with x on this side, and here is 7 times 0.65. So that number, 0.65, roughly, times 7, gives us this let's go to 2 decimal places, 4.55. 4.55. So according to this, that side length there is 4.55 meters. And it's true. So there, the tangent sort of helped you figure out an unknown length. Let's try another one. Let's say you have a triangle like this. There's the angle we know, and we don't know this side here. So, again, we have to identify the sides. That's adjacent. That's opposite. So we need our tan of an unknown angle is equal to the opposite over the adjacent. The angle we actually know is 20 degrees. So tan of 20 is equal to opposite, which we don't know, so we'll call it x, or you can call it O if you want. The adjacent is 5. So there's our thing. Let's do it. First this side, tangent of 20. So we just go 20 tan, or tan 20, depending on your calculator, and this spits out 0.36. 0.36 x over 5. I want to get rid of that 5. It's dividing the x. We multiply by 5 then to get rid of it. That gets rid of the 5's, and we're left with 5 times 0.36, which is, I already have the number there, times 5, 1.82. We go to 2 decimal places, 1.82. I didn't have any units in this question, so we can just leave it like that. So this length there is 1.82. Done. How about this? This one's a little tricky. This one is tricky. I'll show you why in a second. So that is the adjacent. That is the opposite. So opposite adjacent, we need to use our tan buddy again. Tan theta is equal to opposite over adjacent. Tan theta is this. That's the unknown angle, which we have here. So there's our formula. We're going to sub in 55 in for the theta. Tan 55 is equal to the opposite, which is 4, and the adjacent, which is unknown, x. We're trying to find that. Okay, well, let's get rid of this tan thing, tan 55. Let's figure it out what tan 55 is. 55 tan gives you 1.43. 1.43 equals 4 over x. Now, at this point, a couple things are what's possible if you, well, I think I've shown this to you in the past. How do you solve for x when x is in the denominator? One thing you could do is flip both, make this x over 4, and make that 1 over 1.43. Let me explain something to you. Something called cross multiplying, which we actually did above as well, without even knowing it. We just think of cross multiplying. Here's how cross multiplying works. If you've got like a fraction type thing, or a thing in the denominator, and on this side you don't, what you can do is turn any number into a fraction. How do you turn any number to a fraction? You put it over 1. And you crisscross multiply. You take the denominator from this side, multiply it by that side, take the denominator in this side, multiply it by the top number numerator on that side. The bottom multiplies the top. Crisscross. Diagonal, kind of like that. That gives you 1.43x, because 1.43 times x is just 1.43x, and then 1 times 4, which is just 4. And now, x is being multiplied by 1.43. How do you get rid of the 1.43? Well, it's multiplying, so divide 1.43 on this side, do the same on the other side. The x's cancel out. 4 divided by 1.43, calculate that. You get 2.80. We're rounding to 2 decimal places, 2.80. So x is equal to 2.80. So that is the missing length there. That is 2.80. Done. Okay. Now let's take a look at ratio lengths to angles. Let's say we don't know what the angles are. But we know the ratio lengths. How can we do that? Okay. So first off, it's saying I want to find the tan of angle A. What is the tan? Well, let's write the formula first. Tangent theta opposite over adjacent. And we're interested in angle A. That little symbol means angle A. So we don't know what A is. We don't know the angle. So we can just leave it as tan. You can call it A if you want, or theta, whatever you want. Let's just call it angle A because that's what it's labeled as. But we do know the lengths. That is opposite, that is adjacent. So 6 over 5, 6 over 5. What is 6 over 5? Get a calculator. 6 divided by 5 is 1.2. So this is 1.2. Tan A. Now check this out. What we're going to do next is we got to find the angle. So now we're going to find the angle. We're told that we have the angle is going to be tangented with that button on the calculator, and it's equal to 1.2. How do you do that? Bottom line, what are we trying to do? We're trying to solve for A. What's bugging the A? Tangent. How do you get rid of tangent? Now before you say divide by tangent, don't. There's something weird about these three amigos, sin, cos, and tan. They have opposites. Watch what happens to these buttons when I press this inverse button. On your calculator it might be the second function button. When I hit the inverse button, watch what happens to these guys. Sin became sin to the -1, cos became cos to the -1, tan became tan to the -1. When I hit the inverse button, when I punch it back again, it goes back to normal. The inverse button is the opposite. Inverse means opposite, the flip. Okay, and if you remember from exponents, anything to the power -1 means it's a reciprocal of that. if you don't understand any of that, bottom line is, to get rid of tangent on this side, what we're going to do is take the inverse tan, which might, again, on your calculator, it might be a second function tan. On my calculator, so it might have these buttons you got to press. On my calculator, it was inverse tan. And so, again, what it looks like is this. It's tan minus 1. That's what inverse tan looks like. So the opposite of tan is tan minus 1. Whatever you do to this side, you have to do to that side. That just means that these two buttons you got to press. That cancels out. Trust me, they cancel out. They're opposite of each other. So we're left with A. And we're left with 1.2. And then we have to do this tan negative 1, which is the inverse of tan. So all you do in a calculator is you'll put 1.2. Well, actually, let me just do this from the start. Clear the calculator up. You can go 1.2, and this means inverse tan. I'm going to hit inverse tan, and it spits out a degree. 50.2 degrees. Angle A is 50.2 degrees. So you gotta make sure that your calculator has those buttons, either one of those, and it might even have a separate button called tan negative 1. Look around and find it. You also have to make sure that if you're not getting this value, then bring it to me. There's something where your calculator is in different modes, degree modes or radian mode. If it's not in the right radian mode, if it's not in the right mode, you might get a wrong answer. Anyways, show it to me and I'll help you out with that. So that's what you do. The missing angle is 50.2 degrees. So that angle there is 50.2 degrees. Pretty cool. Alright. How about this? Find the angle here. That's another example. Let's say, again, that's the angle, that's the adjacent, that's the opposite. So we know we need tan theta is equal to opposite over adjacent. We don't know what the missing angle is. Let's just leave it as tan theta. It doesn't label it as A or B or X. Let's just leave it as theta here. The opposite side is 6. The adjacent side is 4. 6 over 4 in your calculator, if you don't know, is 1.5. And we need to find what that unknown angle is, theta. But it's being bugged by tan. And like I just showed you in the last example, how do you get rid of tangent? Well, you do the inverse tan, which is tan to the negative 1. Do the same to the other side. Again, I know it's the first time you're seeing this, you're thinking, what is he talking about? But tan to the negative 1 is what I just call it inverse tan. Inverse tan. It's like an upside down tangent. And so we inverse tan this side. Leaves us with just with theta, because the tan and inverse tan cancel each other out. And then over here you're left with 1.5 tan to the negative 1. Or tan or inverse tan. So I'm going to punch 1.5 inverse. Now turn that into tan to the negative 1. Hit that, and I get 56.3. So theta is 56.3 degrees. That is what that is right there. Okay, so a lot to chew on in that lesson. So the world of inverse tan and tangents. I know it's goofy. Practice, you'll get used to it, and eventually kids really like this stuff. So just these two skill testing questions here. By all means, rewind the videos and make it make sense to you. Thanks, bye.